Now let's link circular motion with gravitation. So above we can see this equation, gmm over r squared is equal to mass times velocity squared divided by the radius. So if we have some planet like the Earth, and we have something orbiting it, like some satellite, Earth would be our big M, satellite would be our little m, and it is orbiting around our planet. So there must be some force that's attracting them together. So that force is the force due to gravity. And because there's no friction in space, the only force that's keeping the satellite along its circular orbit is the force of gravity. So that's why we can equate it. The net force is the centripetal force, and the force is causing that net force is the force of gravity. So we can see that the mass, the mass of the satellite, the object orbiting, actually cancels out. So we can actually ignore that. One of the r values cancel out. We end up with the equation v squared is equal to g mass of, in this case, that's the Earth in this case, and divided by however far you are from it. So we can rearrange this equation to the following if we want to solve for velocity. So we're going to use that right now. So it says a geosynchronous satellite is one that stays above the same point on the equator of the Earth. And our first task is to determine the height above the Earth's surface. That's what the satellite must orbit, and the satellite's speed. Okay, so how we start with this one, we always recognize that our centripetal force is equal to the force of gravity, so Ft is equal to Fc. And get gmm over r squared is equal to mv squared over r. But this one, it's not asking us for speed, it's asking for the height above the Earth's surface. So remember, there's another equation for circular motion. It was if we know it's traveling a circular path, the distance traveled is the circumference, so 2 pi r, divided by capital T, so the time, the duration. So we can actually simplify this expression. So this cancels cross off that m first, so little m goes away. We're going to have gm over r squared is equal to, and we're going to plug in v squared, or we're going to plug in for v this 2 pi r over t. So we have that 1 over r still. We're going to replace that v squared, so 2 squared is 4. We have pi squared, r squared over t squared. We keep simplifying this. See that one of our r's are gonna, we can cancel that out or just multiply it through. We end up with gm is equal to 4 pi squared r cubed over t squared. So if we rearrange for r cubed, we get gm t squared over 4 pi squared. Now this is a matter of plugging in our values, and we'll have to end up cube rooting it. In my calculator, I like to actually do the to the power of 1 over 3. So remember, a number to the power of a third is the same as saying the cube root of a number. So when we plug in our values for this one, we end up with a value of r is equal to 4.22 times 10 to the 7 meters. And you may notice that down here it says the answer is 36,000 kilometers. And right now we have a value that is quite a bit bigger than that. That's because it's saying the question is asking for what's the height above the Earth's surface. So if we actually take that number, so the height above the Earth's surface, we actually have to take this number, this 4.22 times 10 to the 7. And we have to subtract from it the radius of the Earth. And if we subtract those two numbers, we end up with 3.6 times 10 to the 7 meters. So question part B is saying, what is the satellite's speed? That's usually the equation we just derived right above. We can say v is equal to the square root of gm over r. Plug in our values. 6.67 times 10 to the negative 11 kilogram meter squared per, newtons meter squared per kilogram squared. And we multiply by the mass of Earth again, that 5.97 times 10 to the 24. And divided by our radius, 4.22 times 10 to the 7 meters. We get a value of 3,070 meters per second.